Amazon just did something that could completely change the future of technology. And no, I'm not talking about faster deliveries or new Alexa devices. I'm talking about quantum computing, and what they just revealed might be the biggest breakthrough of this decade. Imagine a computer so powerful it could solve in minutes problems that would take thousands of years on today's best supercomputers. A computer that could revolutionize everything from discovering new medicines to creating super-efficient batteries. This is no longer science fiction. Amazon just took a giant leap in that direction. Today, you'll discover what makes the Ocelot chip so special, why it's different from everything Google and IBM have done so far, and what this means for humanity's future. But first, you need to understand why this is so revolutionary. Stay with me. In March 2025, Amazon Web Services unveiled Ocelot, their first internally developed quantum computing chip. And don't be fooled by the cute name. This tiny chip, just 1 centimeter square, could be the beginning of an unprecedented technological transformation. Oscar Painter, head of quantum hardware at AWS, got straight to the point. This is a first prototype demonstrating that this architecture is scalable and hardware efficient. But what makes Ocelot so special? The answer lies in how it solves one of quantum computing's biggest problems: errors. Here's the big secret Amazon discovered. And when you understand this, you'll realize why tech giants are betting billions on this race. Let's start with the basics. Quantum computers don't work like regular computers. While your laptop processes information in bits that are either 0 or 1, quantum computers use qubits, quantum bits that can be 0, 1, or both simultaneously. Sounds like magic? Actually, it's quantum physics. And it's precisely this ability to exist in multiple states at once that gives quantum computers their extraordinary power. Ocelot contains 9 qubits in its tiny chip. But here's where it gets interesting. 5 of these qubits are something called cat qubits. The name comes from the famous Schrödinger's cat thought experiment, the one where a cat inside a closed box can be considered simultaneously alive and dead until you open the box and observe. This superposition of states is exactly what makes quantum computing possible. Amazon's cat qubits are small hollow structures made of tantalum containing microwave radiation, connected to a silicon chip. The other 4 qubits are transmons, electrical circuits made of superconducting material. And here's the brilliant trick. Amazon uses cat qubits to store information, while transmons monitor that information. It's like having an ultra-secure vault with specialized guards constantly watching. This is completely different from what Google and IBM do. They use only transmons for everything. Amazon decided to combine 2 different types of qubits, and that changes everything. But wait, there's a massive problem Amazon needed to solve, and their solution might be the key to unlocking quantum computing's true potential. Keep watching. Here's the brutal truth about quantum computers. They make mistakes. Lots of mistakes. Qubits are extremely fragile. Any tiny vibration, any temperature fluctuation, even cosmic radiation from space can make a qubit error. And when you're trying to do complex calculations requiring millions of operations, these errors accumulate rapidly. That's why all current quantum computers are practically useless for real applications. They simply can't maintain the necessary precision long enough. The only way to get a truly useful quantum computer is to implement quantum error correction, Painter explains. But here's the problem. Correcting errors in quantum computers is incredibly difficult and hardware expensive. Last year, Google made headlines by encoding a single error-corrected bit of information. Know how many qubits they needed? 105. That's right, 105 qubits just to reliably store a single bit of information. Now imagine building a useful quantum computer that needs thousands or millions of bits. You'd need billions of qubits. It's simply impractical. This is where Amazon's approach completely changes the game. Amazon's design strategy requires only 1/10 the number of qubits Google needs per information bit. Let that sink in for a moment. 1/10, that's a 90% reduction. In the study published in Nature Journal, Amazon's team encoded a single error-corrected bit of information using only Ocelot's 9 qubits. How did they achieve this? The answer lies in a brilliant discovery about error types. Shruti Puri, a physicist at Yale University, explains, basically, you can decompose all quantum errors into 2 types, bit flips and phase flips. Quantum computers represent information as ones, zeros, and probabilities of both. A bit flip happens when the computer confuses the probability of a 0 with the probability of a 1. A phase flip is an error type unique to quantum computing, related to the qubit's wave properties. Here's the brilliant trick. Amazon's cat transmon design makes virtually all errors phase flips. This means they only need to worry about correcting 1 error type, not 2. The hardware savings come from the fact that you mainly need to correct 1 error type, Puri says. The other error happens very rarely. But the story gets even better. Stay with me. Amazon also solved another critical problem. During the error correction process, quantum computers need to perform operations called C-NOT gates. The problem is these operations normally introduce new errors. Amazon researchers demonstrated that their C-NOT gates don't significantly introduce bit flip errors. This means that after each error correction round, the computer continues making mainly phase flip errors. It's a virtuous cycle the system self-reinforces, and this is absolutely crucial for scaling the technology. But this didn't happen overnight. The story behind Ocelot's development is fascinating and reveals how much Amazon is betting on this technology. AWS started working on Ocelot's design back in 2021. 4 years of intense development, and it wasn't just about putting some qubits on a chip. Painter describes it as a full-stack problem. To create high-performance qubits capable of executing error correction, researchers had to invent a completely new way to grow tantalum, the cat qubit material, on a silicon chip. They needed to do this with the fewest possible defects at atomic scale. We're talking about perfection at the level of individual atoms. And here's something few people know. For years, this was a secret side project within Amazon. The company's main strategy was investing in conventional transmon qubits like Google's and IBM's. But at some point something changed. The team became so convinced of cat qubits' potential that Amazon made a bold decision: make this their main strategy. We became really convinced this needed to be our primary engineering effort, Painter says. We'll still do some exploration, but this is the direction we're going. This isn't a small bet. It's Amazon putting all their chips on a technology they believe will dominate the future. But what does this really mean for the real world? The applications are more impressive than you imagine. Imagine discovering new medicines in weeks instead of years. Quantum computers can simulate complex molecules and predict how they'll interact with the human body, something practically impossible for conventional computers. Think about revolutionary batteries. Quantum computers can simulate new materials at atomic level, discovering combinations we'd never find through trial and error, batteries lasting 10 times longer, solar panels with doubled efficiency. Consider cryptography. Quantum computers could break practically any current security system, but also create unbreakable encryption systems based on quantum principles. Artificial intelligence. Machine learning algorithms running on quantum computers could process massive amounts of data in ways impossible today. Climate change. Precise simulations of complex climate systems, energy network optimization, discovery of new carbon capture methods. The possibilities are literally endless, but there's a catch, and it's big. At the current stage, Ocelot is basically a quantum memory demonstration, Painter admits. It can reliably store information, but can't yet do complex calculations. The next step is adding more qubits to the chip, encoding more information, and performing actual computational operations. But there are enormous challenges ahead. Connecting all the wires, interconnecting multiple chips, keeping everything working at temperatures near absolute zero. We're talking about minus 273 degrees Celsius. Scaling is not trivial, Painter concludes, with typical scientist understatement. Other experts predict quantum computers will need thousands, perhaps millions of qubits to perform truly useful tasks. Ocelot has 9. Amazon's work is a first step, Puri says, but it's a crucial first step. And here's something important. Amazon isn't alone on this journey. French startup Alice & Bob is also building quantum computers based on cat qubits. This suggests it's not just Amazon believing in this approach. There's growing consensus that cat qubits might be the right path. So where does this leave us? We're at a fascinating moment in technology history. Quantum computing is no longer a distant future promise. It's real. It's happening now. And Amazon just showed a viable path to making it practical. Ocelot won't solve real-world problems tomorrow, but it proves the approach works. It demonstrates efficient error correction is possible. It shows scaling this technology is viable. In coming years, we'll see more qubits being added, more chips being connected, more problems being solved. And at some point, maybe in 5 years, maybe in 10, we'll wake up in a world where quantum computers are solving problems that today seem impossible. New medicines saving lives, batteries powering a sustainable future, revolutionary materials changing entire industries. Yeah, the question is no longer whether quantum computing will happen, it's when. And with Ocelot, Amazon just gave us a preview of that future. The quantum race is accelerating, and Amazon just took the lead with an approach nobody expected. The future of computing won't just be faster, it will be fundamentally different. And you just witnessed the moment this started becoming reality. If this video opened your mind to quantum computing possibilities, leave a like and subscribe to the channel. In the comments, tell me, which quantum computing application excites you most? Medicines, batteries, artificial intelligence? I want to know your opinion. And if you want to understand more about technologies shaping our future, check out this video here. See you next time.